Now we're going to portray what happens when two waves of different frequencies but different harmonics act on the same or occur in the same string, and this occurs all the time. So we have this picture of a string of some length and another picture of the string and then another picture of what happens when we superimpose this disturbance and this disturbance to get this disturbance. Let's see how this forms. Now, of course, we have the whole wave train coming from the left and another one coming from the right, the white from the left, the red from the right. And the same thing with this wave train. Of course, this wave train has half the wavelength of this one. So at some instant, these two are going to reinforce. Let's say at the same instant, these also reinforce. So it's clear that we get this waveform and this waveform, which added together give us this waveform. That should be clear how we add these to get this waveform, but let's just point out a couple of things. At the endpoints, both waveforms give us 0, so we get 0 displacement from the x-axis in both of those. At this point, this one has displacement 0, which will be added to the displacement here, which is at maximum, so that at the halfway point on the string, we're going to have this displacement, okay, this y transverse displacement. Okay, now on this half of the wave, this wave and this wave are both positive, so they reinforce so that the wave is going to be higher than either of these. On this half, though, this wave is negative, this one is positive, so it's going to be lower, and we get a shape something like this. It's not very well drawn, there's kind of a bad bump in the thing there, but we're going to just kind of live with that. Now we're going to allow the shorter wave, the one with the lesser wavelength, the second harmonic, or the first overtone, to move a quarter of its wavelength. So a quarter of its wavelength is this, and this from the other end. So it should be clear that we get this situation where the two cancel. Now you should stop and draw what this one's going to do if these two waves are allowed to each move a quarter of a wavelength, one in this direction, one in this direction. Quarter of the wavelength of this wave is this far, so this white wave will move this far, moving the 0 point from here to here, the maximum from here to here, and the wave moving, the reflected wave, the red wave, will move in the opposite direction. Very similarly, when you superimpose these, they're equal and opposite here. This one's 0 here, so that the combined wave will meet this one here, and similarly here and here. And at this endpoint, we get 0 again, maximum in between. We know this to be a sine function, but it's of a lesser amplitude than this one. So we have this hump. So what's happening is this sine function is decreasing in its magnitude. Now what happens if we superimpose this on this? It should be clear that since you have 0 displacement here, then you have 0 to add to any of the displacements here, and you end up with this shape. Again, very similar to the shape we had a quarter of a cycle earlier, quarter of a cycle of this wave earlier, except of lesser amplitude. Now, if we allow the waves to move another quarter wavelength of the shorter wave, it should be clear that the 0 point here is going to move to the middle of the white, for the white wave, and we're going to get this. So what are we going to get for the red wave? You should pause and sketch that yourself, but I'm going to go ahead now, and you should have already paused. It's clear that the red wave, the valley, is going to move over to here, so that the red wave is going to match up with the white wave in such a way as to give us, well, you should draw the combined wave, but here we go, it's like so. Again, we're just doubling the amplitude of each. Now, what's the original wave going to look like as this wave moves a quarter of its wavelength? The white wave started here, was here. This point is going to move another quarter wavelength to the middle, so the 0 point will be here, and the maximum will be here, the minimum, the valley will be here. And what's going to happen to the red? Pause and do that yourself, but here's what it's going to do. And the result is going to be simply where this wave is flat. So that when we add the two, we just get a copy of this one, so that the sum of the two waves is going to look like this. Now, let's move it another quarter of a wavelength and see what happens. Okay, if this wave moves a quarter of a wavelength, then this point will move to, I'm sorry, we're here. This point will move to here, so there's the 0 point, and the wave will look like this. And the the reflected wave is going to move to where the peak moves to here, the valley, and the wave will be equal and opposite, and we'll again get a situation where the two waves add up to a flat wave. Okay, where the propagating and reflected waves of the harmonic here add up to 0. Okay, on the original wave, what do you get? Go ahead and sketch that, and then sketch what happens when you add this, what you get here, to this. The 0 point of the white wave will move over to here, giving us 0 point here, and the wave will look like this. The 0 point of the red wave will move over to here, reflected wave, and it'll look like this. And this picture is just an upside down version of this one, and the result is just an upside down version. Something that was terrible. Let me fix that. Okay, fixed it. I didn't have it at 0 here. These two are opposite, equal and opposite. These two are equal and opposite here. You can't really see where the red ends up there, but I used the wrong color. Excuse me. In any case, when you add these, you get something like this. Again, a lower amplitude version of this, but inverted, just an inversion of this. Then you can go to the next picture and see if you see what you get there. Not going to draw that right now, but what you get is just going to be an inverse of this one. Okay, these waves will move over and reinforce one another to give you an upside down version of this. The two waves here will mesh, this moving over and this moving over, the white one moving this way, the red one moving this way, so that they mesh in an upside down version of this, giving you an upside down version of this. You should be able to fill in the details, but these are the subsequent configurations at quarter cycles of the higher frequency wave. These are the configurations of the resultant wave. We go from here to here to here to here to here and so forth. We could say more, but you should know how to work that out. A little more detail. It should be obvious that the longer wavelength wave is going to go from a maximum to an intermediate to a flat state to a negative intermediate to a negative maximum to a negative intermediate state to a flat state to an intermediate state. While the higher frequency wave goes from maximum on the left to flat to maximum on the right to flat to maximum on the left to flat to maximum on the right to flat. And when you add this behavior to this behavior, you get this. This to this gives you this, etc., all the way down the all the way down the series of pictures. And this gives you a complete cycle. The very next position will be where the longer wavelength wave is at a positive maximum, and the shorter wavelength has its maximum on the left, and that's exactly this process, or this configuration, so that this just continues. So the sequence simply continues until the wave dies out.